because I had written some things before about green chemistry, about the movement of green chemistry, which again is now probably like 20, 30 years old, sort of this idea that the way that we make things in chemistry, chemicals, and all of these different things, they were back when we invented these processes, we didn't care about all the toxic materials that were required to make these things. Didn't think about it, didn't care, all of those things. And now there's like this new way of thinking, a new challenge of like, well, let's make those same things or even better things without using all of this horrible stuff.
Yeah.
And that's, and that's as you described, there's a moral reason for doing that, not destroying the planet and all that. But when you do that, when you view things in that way, you actually unlock a lot of other possibilities. And this Mars study that we've kind of alluded to here is, you guys really said, okay, well, we have gypsum, which is potentially a boring rock, but let's see if we can make nanomaterials out of it, nanotubes, I believe, in a way, like, again, put these constraints on for environmental reasons, but also hypothetically, what could a Mars, like an early Mars base colony kind of thing, what might they have where they could make this, they could produce this material on Mars that they could then use? And it was like, what, like, you need water,
Yeah.
gypsum's already there on Mars, you need water, and you need, I don't know, you could tell me the ingredients, but
Essentially, what the gypsum could be used from is that NASA had a study where they were taking gypsum. Gypsum contains or absorbs a lot of water and holds a lot of water. And they were just proposing that essentially you take the gypsum from Mars, you would then dehydrate it, you take the water out, and you're kind of left with like junk, essentially stuff that can kind of be thrown away or doesn't really have any use. And it's called anhydride, so hence the name is just a dehydrated form of the original material, gypsum. But what we found is that you could take the anhydride materials and you can kind of break them apart into these kind of nanorods and these kind of nano tubular shapes, and you could then use them into kind of plastics. You could put them into networks, electrochemical electrodes, to produce hydrogen gas, so clean fuel on Mars. And then you could also then use them as like, simple electronic materials. Essentially, they were like a surge protector, is that they would they could protect electronics and stuff like that from, power outages and stuff, sudden power outages. But yeah, we use these restraints of, taking this raw material, and you could then mix it in water to be able to make these nanorods. And the thing is that you're already making water from the dehydration process, so essentially you already have the water there. So that's already kind of two of the things done. All you need is some type of blender. I'm sure they're going to eat on Mars, so I mean they would have some type of kind of mixing instrument. I know that they do use so we call them sonic probes. This is the thing I was saying about the sonication, breaking apart nanomaterials. They're also called like homogenizers, as kind of, I guess,
mhm.
an industrial term. And they're used a lot in kind of generic experiments for mixing, and also kind of some biology experiments I know as well. And I know that that's something that they're interested in on Mars, of kind of like you're going to be growing plants. You're going to then need to be able to assess the quality of life of the plants. And you would actually use a homogenizer to kind of break up bits of the plant to be able to kind of like,
To break up the tissue. Yeah,
yeah,
yeah.
to kind of then examine it under microscopes. So they would already have like kind of these homogenizers or these mixers there to then take this water that they just made and this junk that they just made and mix them together essentially to then make these a solution of these nanorods. And the thing is as well is that these aren't kind of toxic materials. So gypsum's used in food products back here on Earth, kind of ground up and put in as a kind of an additive, I think, for kind of calcium, because they're made from they have a high amount of calcium into them, so it's kind of like supplementary kind of food. So I mean, like you could technically have astronauts eat some of the anhydride stuff as well. I mean, like I know that there are issues with kind of bone density and stuff in space and space
Because of
travel
the gravity, right?
because
Yeah.
of the gravity and stuff. So I mean, like I don't know if then them being able to kind of eat the gypsum or eat the anhydride will actually be beneficial to their bones once they arrive to on Mars, that they need like this sudden influx of loads of calcium to help kind of reinforce the density of their bones. And but yeah, essentially we kind of took this whole idea of just like they already have this stuff on Mars, so it's just like in tangent or in parallel, you'd be able to kind of make these kind of very useful materials. And I suppose one of the things, like, I suppose restraints was like, I think kind of the word that we had used in kind of the paper, and always kind of something that I thought of initially when we were doing the work. But I feel like now, kind of like retrospectively looking back, is I feel like it wasn't really like, it's not really like a restraint to use more economical, more, environmentally safe materials, because there's so much of it out there. So it's not really, it's more so just looking elsewhere rather than kind of just being like, oh, we absolutely cannot use these materials. And if you kind of think of another way of just like, there's all this other stuff that we can use instead.
Right.
It seems less kind of daunting than that. It's just, yeah, looking back, I feel like more positive about it. Whereas before I was just like, oh no, we can't use a solvent here. How the hell are we going to get around this? And like, could they use that up there then? No, they wouldn't be able, like, they wouldn't have IPA up there possibly. I guess maybe they might have it for rubbing alcohol if they had wounds, but maybe they wouldn't want to use it, or it wouldn't be in a way that we would be able to process it. So it's just like, at the time it did seem like restraints, but now looking back, yeah, it just seems like it's just, no, there are loads of options there. I think it's just changing that frame of mind of just being like, there are other ways of doing it. It's just I've been taught to only kind of do it one way. And I think it's kind of just trying to move past it. And, at the moment with our other research as well, is that, we've, before we're like, you can't make, good sensors or for wearable sensors out of anything but, like silicone and all these kind of really stretchable, industry available materials. And we're just like, no, like, no, there must be other biological materials that are out there that are ready for the taking. We found seaweed as the kind of the ultimate kind of material that we found that's really, really good at making sensors, that a lot of people just kind of just, I suppose, they probably just don't investigate, because just everyone does polysilicon and solvents and all this kind of stuff. So it's just, people just need to change the mentality all around.
Yeah, I mean, I love that, not looking at it as constraints, but rather, well, look at all of these other materials that are available, right? Like just
Yeah.
flipping that positive negative kind of thing. But it's kind of cool to me that it takes, limiting yourself or saying I'm not going to do things in the way that we've always done them, which again feels like you're giving yourself boundaries, you're giving yourself, this box that you have to operate in. But in doing that, you just, on the other side of that box, you open up this wide open space of all the stuff that is available, which is,
Yeah.
I don't know, like just, I don't know, it's just a neat
I
sort of
think it's just like,
philosophy sort of thing.
thinking about it, it's just like, before I now think like, I had my blinkers on then. I was restraining myself then because I was just like, this is what everyone does and this is how you do it. And I
Yeah.
now feel like that's more of a restraint. It's like, you need to be more flexible. You need to you need to think of something else.
Yeah. Yeah. And then just investigating the things around you. So the seaweed then, what is it about seaweed that you found and how did you cue into seaweed? What gave you the idea for seaweed?
Seaweed came from lockdown and watching MasterChef. Like, the basically it was, they made these things called like food caviar. So it's like they get like pureed prawns or jams or jellies and stuff, and they just mix it with the seaweed polymer, and then you then drop it into a little bath of salts, calcium chloride salt, which is also edible as well. And it would form these little capsules where you would have the jam in the middle, and then you'd have like a hydrogel layer surrounding it. So you could like pick it up and hold and stuff. You might have seen it kind of like in, like, fancy restaurants will try and like, I don't know, put it across as like, ooh, fine dining experience, but it's just literally you're just kind of eating goo. But yeah, I just kind of just had this idea that it was just, that seems really interesting, very firm, very pliable. I was like, well, what happens if we put graphene into it? And that's really where it kind of just spawned from, is that we put graphene into it and just found out that, like, just the system of the capsule itself was just such a cool system that we were able to kind of control so many parameters about the sensors that you can't do with any other material. And it just allowed us to get just a really fine understanding of just generally how nanocomposite, which is nanomaterials mixed into a polymer, how those systems work in general. So, like, globally, we, through this stupid idea of watching MasterChef, we're now able to kind of predictively understand and predict the performances of nanocomposites, not only our own, but other people's sensing materials. just using our modeling just from MasterChef. But it's just like it was just like, it's just something that was just the fact that it was like a sensor that you could eat. I was like that. There's nothing more kind of economical and environmentally safe than that. It's like if you could eat it, and fish eat seaweed and stuff, and the wildlife can metabolize it. I'm just like, this is then like a win-win. It's something that benefits us, but it's not hurting, you know, anyone else.
Yeah, and then you got to think too, like the cost of the starting material. Like if
Yeah.
seaweed is a basic, that's you could grow a lot of seaweed. I would imagine pretty cheaply.
It was,
Uh,
yeah,
you
and
know,
it's very, very cheap starting materials, and it doesn't like use a lot of the material that we bought. Granted, we got completely screwed because the first time I bought it, I went to like this fancy gastronomy supplier and stuff, and I bought the seaweed from them. It was really expensive, and then I then bought the same seaweed off Amazon. It was literally exactly the same thing. And it was like, I think the first time was like £50, and then the next time was like £5, and I think we got double the amount off Amazon as well. Oh, I felt like such an idiot, but I was just there like, I have to get stuff that they got off MasterChef because that might be the only stuff
right.
that works. Oh yeah, we felt like such. Well, I felt like such an idiot, but we got there in the end. But yeah, it was a very unnecessary.